Hi everyone, Ms. Stillman here. This is the homework 5 key for this Unit 8 Part 2. So taking a look at question number 1, we had to find x. So we look at our diagram and we have x, we have 25, we have 65. Well, that 65 is a leg, and that means we're using hills. I wrote out the proportion. Hypotenuse over leg equals leg over seg. Now it matches with that 25. So later on, that's the 25 we're going to put in for seg. Okay, now when we do the hills, we need the entire hypotenuse. So x and 25, to join them together, they must be joined with addition. So that's why in our proportion, the hypotenuse is x plus 25, the leg is 65 in both places, and the segment is 25. Now when you cross multiply, be very careful that that 25 has to be multiplied to both the x and the 25. That's distribution. And when you follow through, you get 25x plus 625 equals 4,225. Then you subtract 625 from both sides, divide by 25, and your x is 144. And that's what we were trying to find. Now the next question was a little trickier because there was no diagram and there was a comparison involved. I'll show you what I mean. In right triangle ABC, CD is the altitude drawn to the hypotenuse AB. CD is 4, and AD exceeds DB by 6. Find the length of AD and AC to the nearest tenth. Exceeds. Well, exceeds means larger. So AD is going to be larger by a certain amount. So when we get to that, I have to put A and B and C on the diagram. Well, take a look. Hypotenuse is AB, so the bottom is A and B. You could have put the the letters on opposite sides, but I just put A on the left and B on the right. What matters now is CD is the altitude, and C is part of the triangle, so C is the right angle, and D is where the altitude hits the hypotenuse. Well, now that we have our diagram drawn, and it's okay if it's not drawn to scale, but we know that AD is supposed to be bigger. Okay, well, unfortunately, AD is not bigger, but that's okay. It's bigger than CD. So DB is our x, and AD is 6 bigger than that. So it's x plus 6. Okay, so now we look at our diagram, and we have to find AD. Well, that's why this is being marked. And then later on, we're also going to find DB, and we're looking here. CD is 4. That's all that's given to us. Now we look at that diagram and we think, oh, the altitude CD is labeled, so that means it's a SAS problem. Okay, SAS is segment over altitude equal altitude over segment. Well, now I can put the numbers in the proper spots. The segment, x plus 6, altitude is 4, repeat the altitude of 4, and the other segment is x. Now I've already set up the cross multiplying to save us some time. X times x and x times 6, it gets you x squared plus 6x equals 16. Well, now this is the first time, other than the lesson, where we have to get our equation in the trinomial form. So move the 16 over, so that x squared plus 6x minus 16 is equal to 0. Now, some people would know how to factor this. We'd think to ourselves, okay, we need to find two numbers that multiply to 16, negative 16, and add to 6. Well, let's get our setup ready. Our numbers are x minus 2 and x plus 8. Let's check that out. 8 times negative 2 is negative 16. And when you add 8 and negative 2, you get positive 6. Okay, so now we're going to solve each of these. X minus 2 equals 0. You add 2 to both sides, you get x is 2. X plus 8 equals 0. You subtract 8 on both sides, you get x equals negative 8. But this question is about lengths. You reject the negative number. So x is 2 is going to be the x value we need. So we come back up here and we put in that x is 2, and over here you put 2 plus 6 is 8. Okay, now we have our diagram with all the numbers on it. Let's see what we wanted. We wanted AD. AD is 8. That answers the first part of the question. Now the second part is finding AC. So AC is over here, and it's part of this triangle on the left. We already know 4 and 8 are on this triangle, so I redrew it over here. Let me add in the fact we just found that AD is 8. How do I find AC? I don't want to use x because I used x on the other side. So now I look at this triangle and I think to myself, this is a right triangle. We solve questions about right triangles with Pythagorean theorem. A squared plus b squared equals c squared. We put in 4 squared plus 8 squared is equal to y squared. You could have left it as c instead of y. You get 16 plus 64 equals y squared. You get 80 equals y squared, square root of that. You get 8.944 going on, and the question says nearest tenth. So that's 8.9, and that is your AC. Now on the next page, we could skip question 3. We've done that one before. But on the bottom, it was a right triangle diagram, and we wanted to know when would these two line segments be congruent? Perpendicular. Oh, I read that too quickly. I need to be more careful. Okay, perpendicular. When would CD be perpendicular to AB? So let's visualize that with the right angles. Oh, well, that diagram looks like our HHLS and SAAS questions. So we take a look at this. The unknown AC is there. It's a leg. So this is a HHLS question. Hypotenuse over leg equals leg over seg. There's the work for you. But we need to do it in simplest radical form. Well, what perfect square goes into 40? Well, that's 4. And the non-perfect square is 10 because 4 times 10 is 40. Simplify that, you get 2 radical 10. That's your answer, number 2. Okay, on the last page, we had a proof. I've worked out most of this for us because it's a review. So we're going to start off by knowing that our given is parallel lines. And we're trying to prove the multiplication step. When I think multiply, I think product. So I know at the end, I'm going to have to say that sentence about the product of the means equals the product of the extremes. I'm going to hold that thought for later. Before I do multiplying, I'm missing similar triangles in a proportion. Let me remind you how to put the proportion in. DB goes on the top, cross multiplied to the bottom AC. Now AB and DE are flexible. I'm going to put AB on the bottom and then DE on the top. Well, now we have the given. We could use reflexive property up here, that angle B is congruent to angle B, and then we can use angle 1 and angle A. Those are corresponding angles. In this explanation, the most important part is to say that the corresponding angles are congruent. We could have used angle C and angle BED. You could have put, let's say, a 2 over here and called that angle C if we wanted, or you could refer to it by these names. That could have been instead of the reflexive property or doing a different pair of corresponding angles. Well, now we show that the triangles are similar by angle-angle similarity. Now, that proportion I thought about in the beginning, I put back in my work because if two triangles are similar, their corresponding sides are in proportion. You could have said because corresponding sides of similar triangles are in proportion. And lastly, you multiply those numbers as segments because the product of the means equals the product of the extremes.